All right. Thanks very much, Vera. Today, I'm going to be talking a bit about the technologies designed to improve the pronunciation of second language learners. We found that a simple, rule-based system was good enough to improve pronunciation in beginners when embedded in a role-playing task. We believe that approaching pronunciation training as an interaction design problem is more worthwhile than typical engineering approaches. But before we get started, welcome to Montreal. It's a great city, especially if you like good food. A favorite of mine is a delicious, stone-baked, slightly sweetened bagel that's specifically made here. If you want to order a Montreal bagel at your local bakery, walk up to the baker and say,
J'aimerais un bagel de style montréalais, s'il vous plaît.
Pretty easy, right? Let's do that one more time.
J'aimerais un bagel de style montréalais, s'il vous plaît.
If you're a beginner learner of French, or even after a few years of experience, repeating it, you might sound like this.
Bagel.
Or maybe like this.
J'aurais bagel, s'il vous plaît.
The point I'm trying to make is that beginner learners need pronunciation training. Without prior experience, beginners cannot perceive certain sounds, have difficulty with the speed and cadence of speech, and can have difficulty articulating those sounds. Developing an ear for a language involves lots of practice communicating in it and receiving teacher feedback. Classroom activities are an ideal place to start practicing pronunciation. In Western schools, students can get this practice through role-playing activities. In them, group members take turns speaking, trying to get their ideas across to others in the target language. A teacher can provide explicit feedback to students, helping them with grammar, understanding, and pronunciation. In most language learning applications, however, users get pronunciation training from read and record activities. Applications like Duolingo have users record themselves speaking a sentence in the target language. The application then decides whether to accept or reject the phrase, maybe highlighting which words the user got wrong. Read and record activities are very different from the classroom, which not only is conversational, but can have very complex feedback from a teacher. The technology responsible for deciding which tokens are right or wrong is the pronunciation error detector, or PED. A lot of effort has been spent improving the accuracy of PEDs, as opposed to finding new tasks or activities that might improve users' pronunciation. Research on pronunciation training so far has evaluated PEDs in either of two ways. The first is intrinsically. In engineering circles, it is common to measure the value of a PED according to how accurately it can say whether a word or sentence was labeled correctly or incorrectly pronounced. These labels come from experts who've listened to the recordings and made decisions outside of any activity. This makes it hard to generalize intrinsic evaluations to real-world performance. On the other hand, holistic evaluation is all about real-world applicability. Holistic evaluation takes the whole activity and sees whether it's of any benefit to the learning process. This can include longitudinal studies over a school term, teacher or student interviews, and other forms of usability study. While this sort of evaluation is very useful for deployment, we can't easily get at how much good the PED itself has done because of all the other things that go into the activity, such as the way that feedback is presented or the user interface. So, in all, we have read and record activities that evaluate their core technology outside of the activity itself, or alongside all the extra baggage of the activity. Ideally, we'd like some way of performing a holistic evaluation, but only to get at the effects of the technology that we're interested in. So we set out to do just that. We wanted to make sure that intrinsic evaluations were worth all that effort in the face of a more realistic experiment. Instead of a read and record activity built for individuals, we wanted to explore how PEDs fared in the role-playing activity I mentioned before. An application plays the role of the teacher by listening into dialogues and giving word-level feedback. But the application is actually being controlled by a teacher behind the scenes. Because this is a Wizard of Oz experimental design, we'll call that hidden teacher the wizard. Critically, the only feedback we alter from the wizard is what the PED is responsible for, whether words were correctly or incorrectly pronounced. We then check what effect those decisions had on the perceptions of both the participants and the wizard. We call this a functional evaluation, since it asks how the PED specifically contributes to the activity. We hope to see whether intrinsic evaluations of a state-of-the-art PED were able to generalize to a functional evaluation in a role-playing activity. For our experiment, we recruited 36 absolute beginners of French. Participants were paired up and asked to complete a series of dialogues. Dialogues were completed over the course of 3 20-minute sessions. Between those sections, the participants were given 5-minute intermissions. It's during these dialogues the wizard can give feedback, but we are going to change that feedback with some from experimental PEDs and see what happens. Sections consist of a series of dialogues that progress through a short French curriculum. Each dialogue highlights some new concept in the language. A dialogue begins with participants watching a video. The video depicts a conversation between native speakers. The goal of the participants will be to rehearse the dialogue together. The conversation repeats in the video with small contextual changes that participants are supposed to adapt to. This is done to ensure that they don't just memorize the conversations. Participants take turns recording lines of the dialogue on a tablet. Those recordings are passed along to the wizard in real time. After each recording, the wizard decides what was said, gives word-level feedback, and ultimately accepts or rejects the utterance. If it's rejected, the participant has to correct her mistakes and try again. This slide shows the UI of our application. All the dialogues are listed to the left. To the right, we can see icons for playing the video, recording lines, whose turn it is to speak, and whether the utterance was accepted or rejected. Word-level feedback is presented above the buttons. The color and formatting of words are used to indicate the type of mistake made, if any. Participants can tap a word to hear a recording from a native French speaker say the word aloud. It's through the word-level feedback that the experimental conditions are able to make their mark. To measure only the PED, we change only what a PED can change. These are the words marked correct or mispronounced by the wizard. We distributed 3 experimental conditions over each of the 3 sections. The 3 experimental conditions are the baseline, where wizard labels are unchanged, a state-of-the-art PED published in engineering literature, and a simple rule-based heuristic PED. The state-of-the-art PED makes decisions based entirely on the audio recordings, whereas the heuristic PED makes decisions entirely by an offline ranking of the difficulty of each word. The wizard is not aware of when and how her feedback has been altered, so her assessments are only impacted by the subsequent performance of the participants. We collected data on a number of dependent variables during the intermissions between sections, including a 1 to 5 score of each participant's pronunciation aptitude according to the wizard. We modeled the dependent variables with a mixed effects model. The section number and experimental condition are both fixed effects, meaning we expect them to provide a constant positive or negative effect on the dependent variables. We modeled the individual participants and the group dynamics between participants as random effects, which can vary but are not inherently beneficial or detrimental to the dependent variables. Overall, we found that regardless of the underlying PED, participants' pronunciation improved over the course of this experiment. However, there were no significant differences in the improvement based on the choice of PED. We also found that group effects, or the group dynamic, contributed far more to improving pronunciation than the choice of PED. So here we've plotted pronunciation scores over both section and experimental condition. The plot on the right is normalized for within subject and within group mean and variance. As you can see, pronunciation score is clearly improving over the course of the experiment. We can also see that by the third section, there's very little absolute difference in scores by the experimental condition. So what do our results tell us about the generalizability of an intrinsic evaluation to our functional one? A standard measure of expert PED agreement in the engineering literature is Cohen's kappa. Comparing our PED's labels to the wizard's labels for each utterance, we found that the heuristic PED was in far greater agreement with the wizard than the state-of-the-art PED. However, the effect sizes of the PEDs on pronunciation score are similarly negative, with a slightly worse effect from the heuristic PED. This means that the intrinsic evaluation predicts a much larger effect in the opposite direction from the functional evaluation. I mentioned that the differences between the effect sizes of PEDs was very small. A much stronger contributor to pronunciation aptitude comes from the group dynamic. One standard deviation of the random effects of pairs is 0.46 on the 1 to 5 pronunciation scale. Contrast this with the difference of 0.08 between the PEDs. Participants treated the experiment like a puzzle and troubleshooted problems as a team, often helping each other when they were stumbling on pronunciation. We observed that the degree to which partners were comfortable working together strongly impacted their overall performance, and the degree of comfort was significantly impacted by age and first language. Overall, we think it's remarkable that a simple, rule-based PED can perform so well in a classroom activity. Though a deployed application would need some simple speech processing to determine what was said, the heuristic PED needs no fancy mechanism, or even the audio itself, to provide useful feedback to participants. We further established that engineering metrics do not always predict the performance of PED technologies in realistic experimental design, and that fostering the interaction between students might be more beneficial to their studies than trying to label things correctly. It's worth mentioning that these results are limited to only one choice of activity, with one teacher doing the assessing over the course of only one day. However, we believe that these restrictions are reasonable when considering the experiment's ecological validity. We used a real-world teacher, a curriculum based on a real-world one, and a real-world communicative task. More research is necessary to determine whether PEDs maintain similar performance over the long term. So we think that our results support a change in the way computer-assisted pronunciation training is viewed. Instead of a highly technical pursuit reserved to engineers, pronunciation training can be viewed as a rich interaction design problem. The key is to shift from a perspective of driving the learning process by labeling things correct or incorrect to facilitating the interaction between students and teachers. For example, had we designed our application to facilitate student-teacher interaction instead of directly validating a PED, then the application might instead try to flag the teacher when it thinks that a student is struggling. The teacher can remain responsible for providing correct feedback, but her time can be more efficiently distributed through the classroom. Since there isn't a need for extensive feedback, flagging could be done with an over-the-counter speech recognizer. A functional evaluation is far more important in this case in ensuring that the technology is performing its role well over optimizing a metric that may or may not even be relevant to the task. We hope to see more HCI practitioners introduce their unique knowledge of interaction design to the problem of pronunciation, ultimately to the benefit of language learners. Thanks very much for your time. I am you.
Yeah, let me start with one. I was wondering, have you controlled the latency? Because I'm assuming the wizard will have a different latency.
Right. We did control. So the question was, did we control the latency? And the answer is, we made sure that all of the assessments always ran at every step so that there would be no difference in latency. So the state-of-the-art, the heuristic, and the wizard all ran at once.
So, but that will mean the latency is actually larger than the usual case in terms of PED.
Correct.
Okay.
But it should be noted that in this case, the biggest bottleneck was the wizard selecting appropriate feedback. So the actual experimental PEDs took far less time.
Okay. Thanks for the clarification.
Sure.